Okay, so today we're going to focus on linear inequalities in two variables. It's literally just one extra step than graphing lines, period. So basically, if I have this coordinate plane here and I graph the line, let's just do this. Y equals negative x plus 4. So if I were to start plotting points that would fit this equation, I'd end up getting the intercepts of 4, 0 and 0, 4. So this line would look like this. So this line represents every single coordinate that satisfies this equation. Now, what if I said, all right, I don't just want all the y's that equal negative x plus 4. I want all the y's that are greater than or equal to negative x plus 4. So all the points on this line still satisfy that equation, but every point above the line also satisfies that equation. Like originally, the point 0, 4 would work. That would fall right here. Now I'm saying y can be anything greater than or equal to negative x plus 4. So the point 0, 5 would also work because 5 is greater than negative 0 plus 4. The point 0, 6 would also work. The point 0, 7. So every point above here would work. Every point above here would work. Every point above here would work, and so on and so forth. So the solution, or the graphical representation of every single point that satisfies this inequality, not equation, inequality, would be this line and everything above it. Okay, so now when we graph, we're not only going to have a boundary line, we're going to have an entire section of the graph that satisfies the inequality. Now, if I said, I don't want y to be greater than or equal to negative x plus 4, I want y to be just greater than negative x plus 4. So that means I want all the points above this line, but I don't want to include the line anymore. So that being said, how do I represent the line but not include it? To do that, we take a dotted line. This is going to be, I'm going to make it red. So if we have a dotted line here, it means that this is still a boundary, but I'm not including it in part of the solution set. Imagine it's like you and your neighbor share a fence, and your neighbor owns the fence. So your property is up to the fence, but not including the fence. Your neighbor's property is up to the fence and including the fence. So this particular case, it's as if we don't own the fence. So it's going to be this entire region up to the line, but not including the line. Okay, so basically you'll see that if it's just greater than or less than, it's a dotted line. If it's greater than or equal to, or less than or equal to, it's going to be a solid line. That's the only new thing we're doing, okay? So it says additional step for graphing inequalities. Let me just type this. We are going to say if, I'm going to make this smaller, if less than or greater than, we use a dotted line. If, I don't think I have a button for that. I'm going to do it like this. Less than or equal to, or greater than or equal to, we use a solid line. So now we figure out, okay, once we've established if it's a solid or dotted line, I have to figure out which side to shade. Well, you can really take any point you want and test it. So let's just say I want to do, all right, well, I know this is the line. Let's see if the point 10, comma 10 works. Oops, I want to do this. 10, 10 works. That's fine, you can do that. But what's the easiest point to test? Well, probably 0, 0. So just for argument's sake, we're always going to use 0, 0. So once we've established what our boundary is, we're going to use 0, 0 as a test point. So we're going to say test the coordinate 0, 0. If it works, shade that side. If it doesn't, to the other side. I'll show you what I mean in just a second. But here we have a very, very simple example. It says graph y is greater than or equal to 1. Well, y is greater than or equal to 1, we know is going to be a horizontal line at 1. So let me just graph that. And since it's greater than or equal to, it's going to be solid. So here we go. We're just going to do, there's our line. Y is greater than or equal to 1. Well, that's y equals to 1. So then I say, okay, which side do I shade? Do I shade below it or do I shade above it? So I'm going to test 0, 0. So I'm going to plug in 0 for x and 0 for y. Well, there is nowhere to plug in x, so I'm just going to plug in 0 for y. So I get 0 is greater than or equal to 1. Well, 0 is not greater than or equal to 1. That's false. So 0, 0 doesn't work. So this is the wrong side of the line to shade. So I'm going to shade above the line. Okay, this entire solution set answers the question, well, what values of y are greater than or equal to 1? It really makes more sense when you have x and y, so I'll show you this one here. Okay, so I'm going to start. So for all these questions, really, I would just say start by pretending this is just an equal sign. Okay, ignore the inequality, make it an equal sign. So we have x plus 2y equals 4. This is in standard form. So I'm going to start by graphing it by using intercepts. So I'll say let y equals 0, solve for x. So I have x plus 2 times 0. I have x equals 4. So I have the coordinate 4, 0. That's my x-intercept. Just like we did last class, I'm going to say, okay, well, now let x equal 0. Solve for y. So we'll let x equals 0. I have 2y equals 4. So I have y equals 2. So I have the coordinate 0, 2. So there's my two intercepts. 4, 0 right there, and 0, 2 right there. I'm going to connect them with purple. Red plus blue makes purple. Whoops, I want a line, not a squiggly line. There's my boundary, okay? So I have to figure out, okay, do I want to shade below it or shade above it? Well, I'm just going to take 0, 0 as my test point. Does 0, 0 work in the equation? If I plug in 0 for x and 0 for y, I get 0 plus 2 times 0 is greater than 4. I get 0 is greater than 4. So 0, 0 gives me a point that does not work in my equation. So this point is bad. So I know this is the wrong side of my boundary. So the right side of my boundary is going to be above it. That's it. Okay. So it's just like graphing a regular line and then testing 0, 0. And if 0, 0 works, that's the side you want to shade. If 0, 0 doesn't work, you want to shade the other side. Let's try this one now. It says negative x plus 2y is less than 2. Let's graph using intercepts because it's in standard form. So we'll let x be 0. Solve for y. I get 0 plus 2y. Remember, treat it like an equal sign. Equals 2. So I get y equals 1. So I get the point 0, comma 1. Now we're going to go reverse. Let y equal 0. So that y equals 0, I get negative x equals 2. So x equals negative 2. So I get the point negative 2, comma 0. There's my intercepts. 0, 1, and negative 2, 0. The only time you can't use 0, 0 as a test point is when your line goes through the origin, but that very rarely ever happens. So there's our line. So then I'll say, all right, well, which side do I shade? The bottom or the top? So I'm going to test 0, 0. Plug this into the equation. I get 0 plus 0 is less than 2. I get 0 is less than 2, which is true. That's good. 0, 0 seems to work. So the 0, 0 side is the side I want to shade. So that's going to be my solution set. That's the answer to that inequality, this entire region of the graph. Okay, example 4 works the same way, except this is just written in y equals mx plus b form now. So I'll start by graphing it. So this is my m. This is my y-intercept. So I'll start at 0, 7. 1, 2, 3, 4, 5, 6, 7. From there, I'm going to go up 2 over 1. Boom, boom, boom. Oh, up 2 over 1. Those are my 2 points. I'm going to connect them with a solid line because it's greater than or equal to. Like that. Now I have to decide, okay, which side should I shade? Do I shade the 0, 0 side or the other side? Well, let's test 0, 0. I plug in 0 for x, 0 for y. I get 0 is greater than or equal to 0 plus 7. 0 is greater than or equal to 7. Not true statement. That's a false statement. So this point does not work. So I don't shade that side. I'm going to shade the other side. So that's my solution set to this equation. Okay. So you can give these, I would say skip 6. It's just intentionally messy, but you could take some time and try all of these. I think on our My Open Math page, there's a fair number of these. I think next class, we're going to take some time and figure out how to graph them on My Open Math because it can be a little tricky. Let's see here, linear programming. Nope, I want graphing inequalities. That's what I want back. Let's just go over these together real quick. So let's see here. Okay, so if I have this one, graph y, let's do one that's a little bit. If I have this one, graph x over 3 plus y over 5 is greater than 1. So let me just copy this. So like before, I said I hate denominators, so I'm going to start by getting rid of these denominators. So I'm going to multiply this entire equation by one number that will get rid of the 3 and the 5. So I'm looking for the smallest number. It doesn't have to be the smallest, but the smallest number that 3 and 5 go into. So I'm looking for the lowest common multiple of 3 and 5, which is 15. So I'm going to multiply every single term by 15. So I get 15x over 3 plus 15y over 5 is greater than 15 times 1, which is 15. So if I pick the right number, which I did, these will reduce. 15x over 3 is 5x, plus 15y over 5, which is 3x. I'm sorry, 3y is greater than 15. So I have an equation that's in standard form. I said before, if I want to graph this, the best way to do it is by using intercepts. So I'll let x be 0. So this term is basically going to go away. So I have 3y equals 15. So I have y equals 5. So I have the coordinate 0, comma 5. Now if I let y be 0, I have 5x equals 15. I have x equals 3. So I get the coordinate 3, comma 0. So there's my 2 points, 3, comma 0 and 0, comma 5. So you're going to have to do this all in one step. So I'm not going to graph anything yet. I have to figure out, okay, well, which side do I graph? Do I graph the 0, 0 side or the non-0, 0 side? So I'm just going to plug in 0, 0 into my equation. The green one's fine. And see if it works. So I have 5 times 0 plus 3 times 0. I have 0 is greater than 15. This is false. 0 is not greater than 15. So I know the 0, 0 side doesn't work. So I'm going to go back to my graph. I'm going to say, okay, my intercepts are 0, 5, and 3, 0. So let's start by graphing them. 0, 5 is right here. I'm going to do a dotted line because it's just greater than 0, 5, 3, 0. And I said the 0, 0 side doesn't work, so I'm going to shade above. You can put the point anywhere you want as long as it's above the line, and that's going to be your answer. It's a little tricky, but you have to figure out everything before you graph it, okay? Both intercepts and which side the shade, and that's going to be your final answer.